variables for them. So rubber sheeting is about, let's say, actually right now, like we talked about before, if you have the new raw image and you have the control data, we take the image matching and then we have those matched points. And in order to correct the image, to become the, for example, like the offshore image, two possibilities. One is you have those control points, and you can perform, for example, like the mathematical model. You can perform the bundle adjustment to correct it while obtaining the object space coordinates. That's what you can do. But however, there's the other way that you can do is, do you have those large amount of points like this? Then you can apply for the local region. You can derive the small, you can derive the mapping function between the raw image to the offshore image, and you resample each of the small region so that it match with the offshore image. Right. So for each of the small region, you derive one mapping function and then resample it to become the offshore image. In this case, because you have a large amount of matched points, in this case, the new transformed image, you can assume that it has a very similar projection of behavior like the offshore image. So this is called rubber sheeting. You use a lot of transformation functions for each small region, transform it to the offshore image, and so you have the offshore image from your raw image. So this is another way you can do what you can do, and actually, it's a pretty efficient way. It's actually a pretty efficient solution. And what I know of is some of the ground receiving station they use this way to perform the offshore replication. And some of them they are using this approach. So rubber sheeting this mathematical model is very easy. It's just like a fine or more coefficients like this. You could have a more coefficient over here. But however, it's just a very simple rubber sheeting, very simple linear equation to transform it locally. Okay, so yeah, kind of like that. Rubber sheeting. Yeah, kind of like that. Okay, so let's move on. And bundle adjustment. Of course, you can use bundle adjustment and directional referencing. As you can see, this equation is, I believe you guys see this equation a little bit familiar. This is the state vector that we talk about, the observation vector. We have a lot of transformation. The transformation this is the S is the scale. This is the observation vector, and oh, you guys forgot it. I can see that from your eyes. Okay, so later on we will see some figures. Then you remember that. RFM, and then our friend, basically this is the RFM. And after you have the RFM, then you will refine it by using the ground control points. So that's the last one. So, and yeah, here are some of the coordinate system, the Earth-centric, and the ECF, and body frame. So we talk about the body frame, right? So we have gradually have many transformation, and body frame is one of that. Is using the center of the satellite as the origin, and it defines the X, Y, Z. And LV, LH, that's the local vertical and local horizontal frame. That's the other coordinate system. And this is the angle point. Yeah, it's the rubber sheeting. So we have two images, and after you get those control points, and then you can register them together by deriving multiple transformation function. Okay, which is called the rubber sheeting. So in this solution, this example is for each of the team, each of the triangle, they will have the mapping function, and then to transform it to another image, and then resample it. So that's the rubber sheeting. I believe you guys know rubber sheeting, right? 橡皮伸缩法. Do you know rubber sheeting? Do you guys know topology? Ha! Yeah, good. Alright, if you don't know topology, then you should look it up because it's kind of like one of the like GIS 101 information, something like that, and it has something a little bit something to do with troubleshooting. It has something to do with that. So if you don't know it, take a look because we don't have that much time. Well, we are already out of time. Sorry. I will wrap it up very quickly. Bundle adjustment. Yeah, you guys know it. Okay, so director referencing. Like this. I believe you guys, I drew this before, so you guys should know it. Director referencing is like that. And RFM. This is RFM. Alright, so you guys know this as well. And yeah, so here is how you can get the you can say the anchor point to have a lot of control points to derive you can say the RPC. That's the case. Yeah, I believe this is covered before, so should be fine. And elevation control. This is what the Professor L.C. Chen their group proposed before. So if you want, you can take a look. All right, so let me just wrap it up with the final chapter, which is very easy. It's about cyber city applications. So yeah, it's very easy. It's application. We can construct the cyber city buildings, and then after that, you can, for example, supposedly this is a video, but however, it's not moving anymore, so it doesn't matter. So this is NCU, and we construct the NCU building model, and then we can apply some simulation, including fog simulation, and at night, and also raining, and also if you are under the water, for example, like that. So you have like if the NCU is underwater, then the whole Zhongli district is underwater. Yeah. So that's hopefully it won't happen. Okay, so that's the case, and Taipei is something like that. You can reconstruct those building models, and then you can visualize it by using different simulation and like that. So, well, it's just the application of cyber city as well. And here's some meaning of cyber city, definition of cyber city. You can take a look by yourself. Well, these are other things. A little bit old, actually. This is a little bit old information, so you can find more new information online. Construction. Okay, how to construct it? You can have the frame module, and then you can have the block module, and you can attach the textual on the wall, and this is called textual mapping. And then you can apply the whole also image, and yeah, that's the case. So gradually we can add more and more information. Here are some other GIS related content of here, so you can take a look by yourself. Okay, so frame, block, photorealistic, and also cyber city. So yeah, that's the case. Here are some ways you can describe the building model, and you can take a look by yourself. But one important thing is about the level of detail introduced by the CTGML. Level 0, level 1 is like a block model. Level 2, you have some building rooftop objects. And level 3, you have the window, you have the door. Level 4, you can go inside the building. So that's the standard, the CTGML standard. But however, they are refining it. They will have a new level of detail for the next version of CTGML. So this will be refined, just for your information. Okay, so yeah, here are some applications. How to reconstruct it. There are many ways to reconstruct it. I'm not going to talk about that, but your presentation, your paper presentation will cover some of them. Data-driven and model-driven. I believe both of the paper has been picked, so we will talk about that later, after your presentation. And yeah, so that's the case. Yeah, point-based, line-based. Someone will feel very familiar. This is the one of the paper that one of you choose. It's called SMS, shift, merge, and split, merge, shift, right? And module-based, and so on and so forth. yeah, goes on. Oh, jump information away to Second Life. Okay, anyway, so but still, well, I thought that's the last page. Okay, anyway, so yeah, because they have some hyperlinks inside the slides. So basically, this whole chapter is about like cybersecurity applications and how to reconstruct the building models. So should be fine. You can take a look by yourself. That will be everything from me in this course. So later on, it will be your presentations. So any question for all the information, all the content that I introduced? Any question? If not, then let's go have lunch. Alright, so yeah, that will be it, and then I will see you guys well 2 weeks later for this course and for your presentation. So and yeah, that will be it. And